All right, so here's what I want you to do. You should be on 11.7. I'd like you to set up your calculator so it is in radians. I'd like you to check your calculator, make sure it's got a reasonable scale, so something like -10 to 10, -10 to 10 for both domain and range. And then I'd like you to go ahead and graph those two functions that are written down there. I want you to take a look at it, and I want to make some observations about that. And that would namely be y equals sine x, and y equals x minus x to the third over 6 plus x to the fifth over 120. Go ahead and try that out, and I'm going to pause this. Go ahead and pause. And 3, 2, 1, pausing. Start this up when you are ready to look at the graphs. All right, if you're ready to look at the graphs, here's what happened when mine happened. So what you see here is you've got one graph, which is a sine graph, looks like this. And then you got something coming in that hooks into it, stays with it a while, then pops back out. So that's interesting because for a while there, it follows the sine curve. Okay. Now I want you to go ahead and try C and D. Go ahead and try C and D. Again, I'm going to pause it, get that graph done, and then I want you to make an observation. You should make a slightly different observation than from the one you had before. So make sure you see if you see anything different, you actually watch for it. 3, 2, 1, pausing. Now, here I am graphing it. Now it's following it, and it's following it in a slightly different place. Now you might not have recognized it, so let me show you this. I'm going to go y equals, and I'm going to turn on that second graph so you can see the second graph as well. When I do that, it should do them in order. Hold on, I'm going to shrink this down, hit enter, turn on that graph, and then I'm going to blow it back up. I'm going to hit graph. Here we go. So there's our sine graph. There's our first graph. Here comes our second graph. So it follows it a little bit longer. Now what have I done? All I've done is I've added on an additional term. I want you to notice the following. The very first one that we had looks something like this. We had y equals x minus x to the third over 3 factorial, that's what 6 is, plus x to the fifth over 5 factorial, that's what 120 is. Again, 5 factorial will be 5 times 4 times 3 times 2 times 1, which is 120. So because of that, the next one we did, which gave us a slightly better answer, looked just like it, except that all I did, 5 factorial, I added on x to the 7th over, indeed, 7 factorial. 7 factorial is 5040. So with that in mind, I got a better approximation by adding another term. You want a better approximation? What would the next one look like? Go ahead and figure that out and then add it on. By the way, for those of you who have the TI, the factorial button can be found. The factorial button can be found by going to math, which is right here. I don't know if I can show you that. Hold on, it's right. It's one or the other. There you go. Math right there. Okay. And then you want to go right arrow, right arrow, right arrow to probability, and then down to 4. And that gives you a factorial button to play with. Okay? That makes sense? So you could do that instead of having to figure out what 9 factorial is if that's where you're going. Go ahead and do that, figure it out, and then you should then get an even better approximation to do that right. I will meet you on the other side. Pausing in 3, 2, 1, pausing. All right, so if you were to graph all 3, I gotta turn on the next one. Again, all I added on was the 9x to the 9th over 9 factorial, right there. I'm gonna hit enter to make sure it's on. And then I'm gonna move it back like this so you can see the graphs come in one at a time. Here comes our graphs. There's our sine graph. There's our one that ends with the x to the 5th. Then our x to the 7th coming in now. X to the 9th after that. Again, a couple more pixels over. And so what we discovered is, that you can actually write sine x completely legitimately as x minus x to the 3rd over 3 factorial plus x to the 5th over 5 factorial. Oops, I did it wrong. Yeah, 5 factorial. Minus x to the 7 over 7 factorial plus x to the 9th over 9 factorial minus dot dot dot. Problem with this is what? Problem is that in order to get a perfect estimation, you'd have to go to infinity, do all the terms. So it might give you a good approximation for the first 2 or 3 terms, but it's not going to give you a perfect one until you take it to an infinite number of terms, and who wants to do that? All right, you're going to do the same thing with cosine. Do the same thing with cosine, and then and before you do that, let's go hop down to e to the x. Is e to the x down there? I'll go ahead and give you this one. It's 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial plus dot dot dot. Well, as you're wondering where the 1 comes from, if you think about it, that's x to the 0 over 0 factorial. And you're supposed to know 0 factorial is 1. You might not. This is x to the 1st over 1 factorial, which is also clearly 1. But usually people don't write it that way. So you have sine now. You have cosine. You have e to the x. Go ahead and derive out cosine x. Take a look. Make sure it matches as you see fit. There's an example how to do the problems in the back. So you should be good to go. So go ahead and try out all the problems, and make sure the cosine works mentally first before you move on, and then go ahead and do the problems in the back.